Picture this. It's a cloudy afternoon in 2008, high above the beautiful south coast of France. Inside the cockpit of a state-of-the-art Airbus A320, the pilots suddenly find themselves in an absolute battle for their lives. Their plane, a marvel of modern tech, seemed to have developed a mind of its own, and it felt like it was doing everything it could to plunge into the Mediterranean Sea.
I mean, this was literally a pilot's worst nightmare. The very systems, the software that's designed to keep you safe, to prevent you from making a catastrophic mistake, were now the enemy. They were fighting their own aircraft, second by agonizing second.
So, you gotta ask, how on earth does something like this happen? How could one of the most advanced, most protected airliners in the world suddenly turn on its highly experienced crew? Well, to get to the bottom of that, we have to rewind the clock a bit.
All right, so to really get what went wrong here, you have to understand that this was not your average, everyday passenger flight. Not even close. This was a very specific, very demanding kind of mission.
The mission was called an acceptance flight. See, this Airbus A320 had been unleased to a German charter airline, XL Airways, and now was being handed back to its owner, Air New Zealand. So this flight was basically the final exam, a whole series of tough, in-air tests to make sure the plane was in perfect shape before going back into service.
And on board, you had 7 people, and these guys were all pros. 2 pilots from XL Airways were flying the plane, with a senior captain from Air New Zealand looking over their shoulders. And in the cabin, you had 3 engineers and a safety inspector from New Zealand's government. This was a plane full of experts, ready to put the aircraft through its paces.
You know, in aviation safety, they talk about accidents being like pieces of Swiss cheese lining up. For a disaster to happen, all the holes have to align perfectly. Well, the first hole in this story was punched weeks earlier because of a seemingly small shortcut taken on the ground.
So, after the plane got its new paint job, it needed a wash. Now, the official procedure is to use cloths. But to save time, the maintenance crew just grabbed a high-pressure fire hose. And here's the crucial mistake. They didn't put protective covers over the plane's angle of attack sensors. That high-pressure water blasted its way inside 2 of the 3 sensors, and it just sat there, completely hidden.
Okay, so these little veins you see here, they might not look like much, but they are the absolute bedrock of the Airbus's safety systems. They're called angle of attack, or AOA sensors, and their job is to tell the plane's computer brain exactly how the wing is cutting through the air. If that angle gets too steep, the wing can stall, and the plane can fall out of the sky. The computer depends on this data to make sure that never, ever happens.
So we've got this hidden mechanical time bomb ticking away inside the plane. But for that bomb to actually go off, you need another piece of the puzzle. You need the next hole in the Swiss cheese to line up. And this time, it came from a series of human decisions made under pressure in the cockpit.
The crew's original plan was pretty straightforward. Fly out over the Bay of Biscay, use a specially reserved block of airspace to do their tests, and then head back. But air traffic control, a little nervous after a similar flight earlier, said, "Nope, request denied." This completely upended their plan and forced them to improvise, trying to cram all these complex tests into a much shorter flight.
Now, one of the riskiest tests they had to perform was a check of the plane's low-speed protections. This means you are intentionally slowing the plane down to the very edge of a stall to make sure the safety systems kick in. And the flight manual is crystal clear on this. This maneuver must be done above 14,000 feet. You need that altitude as a safety buffer, plain and simple.
But they were running out of time. They wanted to get below the clouds to have a visual on the ground, so they made a fateful decision. They chose to do this incredibly dangerous test not at 14,000 feet, but at just 3,000 feet, flying low over the sea. They had just thrown away over 10,000 feet of their safety net. And look, this wasn't just one pilot making a bad call. All 3 highly experienced pilots in that cockpit agreed to do this. The pressure of the tight schedule, maybe combined with a little overconfidence in the plane's amazing technology, led them to break one of the most fundamental rules of flight testing.
And this is it. This is the moment where the 2 failures, the hidden water in the sensors from the ground and the dangerously low altitude test in the air, are about to converge with absolutely catastrophic results.
Remember that water that got forced inside the sensors? Well, earlier in the flight, as the plane climbed up to its cruising altitude, the freezing temperatures up there turned that water into solid ice. This locked 2 of the AOA sensors in place, stuck reporting a normal angle of attack. They were now feeding the plane's brain dangerously wrong information.
Now, the pilots felt safe because the plane was operating in what's called normal law. You can think of it as a full-time digital guardian angel. In normal law, the computer simply will not let a pilot stall the plane. It doesn't matter what they do with the controls, the system provides a protective envelope. It gives you this incredible, almost invincible sense of safety.
But when the system gets really confused by bad data, it can essentially give up. It can downgrade to what's called direct law. And as you can see, in direct law, all those protections, they just vanish. The guardian angel is gone. The pilot is flying a conventional plane again with a direct connection to the controls. You're in charge, but you're also totally on your own.
Let's walk through these final, terrifying moments. The crew starts the test at 3,000 feet, pulling the power back. The plane slows, the nose pitches up higher and higher, but the two frozen sensors keep telling the computer everything is fine, so the automated stall protection never activates. Then, the one good sensor finally screams, "Stall!" This conflict completely confuses the system. In an instant, it drops from the safety of normal law into the danger of direct law, stripping away all protections. At that exact same moment, the horizontal stabilizer, which the computer had automatically trimmed to a nose-up position, freezes right where it is. The pilots are pushing the stick forward with all their strength, but the plane is physically trimmed to climb. It's fighting them. And with no altitude to spare, they enter a stall they just cannot recover from.
The crash sent shockwaves through the industry. The investigation had to figure out why a plane designed to be almost impossible to stall had done exactly that. And the answers they found would lead to some really critical changes in aviation safety.
So here's that devastating cascade of failures, all laid out. Because two of the three sensors were frozen, the computer's voting logic sided with the faulty majority and ignored the one sensor that was telling the truth. This meant the main stall protection never even engaged. When the stall warning finally did go off, that was the trigger that caused the system to just throw its hands up and drop into direct law, leaving the pilots with a plane trimmed for a climb they didn't want, with no automatic way to fix it and no altitude to save themselves.
As a direct result of this tragedy, things really did change. Acceptance flights are now super strictly regulated, with pre-planned tests and firm rules on altitude. Maintenance procedures were rewritten to make it mandatory to cover critical sensors during washing, and pilot training was updated across the board to better prepare crews for that sudden loss of protections and the absolute need to know how to manually control the trim in an emergency.
The story of Flight 888T is just such a powerful, sobering reminder. It shows how two small shortcuts, one with a hose on the ground, one with altitude in the air, can line up just right to defeat our most sophisticated safety systems. It really leaves us with a critical question. As our technology gets smarter and smarter, how do we guard against our own human complacency and make sure our vigilance never ever wavers?